So I want to talk to you guys a little bit about a JavaScript rover. I'm Kadom. I work for a company called ThoughtWorks. And I actually have, just for my own edification, how many people have actually heard of ThoughtWorks? Oh, wow. Okay. It's funny, like when you talk to business people, it's like nobody raises their hand. You talk to technical people, it's actually quite a few. We're in Atlanta, and what happened recently is we've had a little thing at work called 100 Days of Hardware, where it was kind of a challenge to thought workers across the world to say, do something fun with hardware, because we think embedded devices and Internet of Things, those things are sort of on the horizon and maybe not getting enough attention from the development community. Getting our devs to think about Bluetooth, low energy, and just what can you do with hardware was just sort of an idea. It was a challenge that came out. People did this in their spare time. So what I ended up thinking about was, well, I've been wanting to learn JavaScript a lot more. I started doing Ruby a long time ago, and about 3 years ago, I got interested in JavaScript because, full disclaimer, I know I'm talking to a JavaScript group, but I originally thought JavaScript was really just for tying events up in the browser. And when Node came out, I was like, wow, you can use this stuff on the back end too, and I can basically do something really cool. I was also really impressed with the fact that you have multiple companies building JVMs, and so there's essentially, or virtual machines for JavaScript, not JVM particularly, but what is it called? EMCA script now, that's the runtime. So you have Google, you have Apple, you have Microsoft, and they're all competing to create these sort of really efficient runtimes. And I thought that's pretty cool. So if you're looking at a language, it's actually not a bad language to get more familiar with. So what we do a lot at ThoughtWorks is use Google Hangout. And one of the things that's a challenge is we have offices all over the world. So we have folks that are trying to talk to someone in Atlanta, and we do use Google Hangout for that, but sometimes you might not have the person there. So what we were thinking about is, well, what if we built a little rover that could just basically move a Hangout around? We had people with a tablet, they would basically carry the tablet around. But what if you could actually do this from inside Google Hangout? And of course, Google gives you this wonderful little API. It's called Google Hangouts API. And if you guys have ever looked at it, it's really simple. There's sample source code for it. And what you can do inside a Hangout is create some controls. You can create your own custom application if you like. Have you people used Hangout before? How many people? Show of hands. So pretty popular, right? And it's so, hey, there's Lance. It's something that happens quite a bit, right? I mean, for us at work, we have pairing. So there's people that are calling from Brazil, and they're always talking daily in stand-up, and fairly common tool for us to use. So what I was thinking about is, what if you connected Google Hangout to a rover, and what would that look like? So if you think about it, you had some kind of a hardware piece, and I'll talk about it in a little bit, but let's imagine this guy can run like a full Linux stack. If he was running a web server, that web server could just basically expose these sort of endpoints. And in this case, I'm also, since I'm local here, I'm on my local network, I need to also make sure he's reachable externally. And the reason he has to be reachable externally is because Google Hangout allows you to define a number of callbacks. So in this application that you can build inside Google, you can say, well, when this button is pressed, call this URL. So essentially, what I'm doing is saying, all right, I'm going to put a bunch of buttons in this Google Hangout, and they're going to tie right back to these URLs. And this other thing I have going on here is just a phone, right? And this is running a Google Plus app. And there's a to-do here, but I'll show you guys how this works at the end. This entire idea is essentially a prototype for, let's build a larger robot like based on a robot, something that can maybe charge itself and is pretty cheap, so that someone could log into maybe a chat room and just take over in the Atlanta office, go find somebody and start talking to them. And then probably we'll hook up a Nerf gun or something so you can shoot them. Because just talking to them isn't going to be enough, right? That's the next step. But the idea here was just, can we do this? This is really a proof of concept. Does it work? And it didn't actually take all that much code. It seems like it might be a little bit complicated, but Express Server, for those who don't know, this is just a little web server for Node. It's something where you can pretty much just kick up scaffolding. So essentially, even if you didn't have anything, you can create your own web server with one line. It's similar to Ruby, basically just stand up an empty framework web server. So I've just patched in a few things in there. Altogether, If you consider the code that's been written for this, you've got Hangout XML, which is really just a little piece of presentation logic that shows the buttons. And then you've got a little piece inside the Express server here that's controlling the hardware. And that is also leveraging BoneScript. And I know if you guys, I've heard a few people tell me that about 3 months ago, someone presented on the BeagleBone, and that's what I'm using here. So if you have some knowledge about the BeagleBone, it should already be helpful. But it comes with sort of a Java stack, an IDE called Cloud9, which you don't have to use just for this. It's actually a nice JavaScript IDE. And it leverages a library called BoneScript to talk to the hardware. So it's really very simple to turn on and turn off some of these switches. All right, so I wanted to get into some code, but before I do that, I'll talk a little bit about the BeagleBone. This is the hardware that I chose. I could have probably also used Raspberry Pi. And someone told me about a new piece of hardware that's coming out called what is that? Anybody remember what that was called? It's a Java JVM piece or something that just uses... What's it called? Tessel. So that might have been even better because that's all Java. But this is nice. It's a full Linux stack, so you can essentially do anything with it. I use it for JavaScript. You can use Python. You can run C. You can run Ruby, Perl, whatever you want. There's a number of libraries out for this. And the reason I showed this is when I show you the code in a minute, you're going to see some of this. But what this is, these are the sort of hardware, or let's just call them identifiers for these ports, right? So here you've got all of these little input-output, general GPIO ports, general purpose input-output, 2 layers of them. You've got like power over here. So when you look at this, it'll tell you, okay, so this is your 3 volt, this is your 5 volt, this is system 5 volt, which passes through a little bit more amp. I don't have to give you too much detail here, but the point of this is all of these things are available for you to program against. And this is really exciting because when I first started playing with robotics about 20 years ago, I had to build my own microcontroller. And actually, I guess you could have bought a Cricket back then, but even those things were really expensive and not very accessible. This board is 45 bucks. The Raspberry Pi is $39. You can get an Arduino for about 20. It's incredible how cheap this stuff is now. Incredibly accessible. There's a lot of stuff out there. If you go out on the web and look for an Arduino, how to do something with an ultrasonic sensor or something to see like I want to do distance sensing, whatever it is, it's amazing how much stuff comes back. So it is so accessible for even someone who's never done anything with robotics to just get started. So the reason I picked this board, I happen to like the idea of doing this in JavaScript for my own edification. And it's actually a little bit more powerful than a Raspberry Pi. It's more geared towards hardware, more geared towards people tooling around with circuits than the Raspberry Pi is. And it's not a ding on the Raspberry Pi. There's a lot of things that the Pi does that are nicer than this if you're trying to set up, I don't know, maybe a build wall, or if you're trying to do more input-output. The Raspberry Pi has more ports and options. Any questions on this before I jump into code? Just a high level? Okay. Yeah, back here.
Processor speed, I mean, what is it, ARM?
This is an ARM-based CPU. It's 1 gigahertz, but it's the next generation from the Pi, so you actually get some of the super scale. I don't know what they did, but they did something internal to it that was also an optimization. So it's not just the clock speed. You're actually getting a, I don't know if it's doing some sort of parallelization or something inside the chip. I'm not sure. Some pipelining thing where it's running instructions faster.
Faster processor than Pi.
Faster processor than Pi. This has 512 megs of memory. I think the Pi has 256. This comes with an onboard flash. So essentially, you don't need to get a little SD card to get it started right out of the box. You can hook this thing up into your USB port. You can SSH to it, and we'll SSH to it, this guy in a minute. But yeah, it's much easier to get started with too. I will say this though, if you're just starting with electronics, I would highly recommend you start with an Arduino, because you're probably going to blow it up a few times. You're probably going to mess up a few things where you hit the ground. And you get really sad when you blow this guy up. It just, he makes me happy. So the Arduino, I don't, you know, it's okay, I can get another one. But this one, I feel like some kind of emotional attachment. So it's not that good if I blow this one up.
Well,
very happy.
Sorry, that's 512 RAM. What about storage?
So it's got 2 gigs of flash memory on here, and then you can put a micro SD card as well for up to 8 I think 1632. I don't even know if that's limited based on what your SDMMC.
SDMMC, okay.
Yeah.
Is the CPU, is it single core or multi-core? Or?
I think it's single core, the ARM, but it's doing some kind of super scalar pipelining thing or something. So it's actually, I don't know what, there's some optimization over the previous. It's the A6 versus the A5, but it's the same chip that you get, same family as you have in the Raspberry Pi, so it's an ARM processor. Okay? All right, so I want to show you some code. I'm going to jump into command line here. So I've got this little guy that you might have seen blinking. He's been running for a while, so hopefully he's not going to be too mad with his battery power. But put him out here somewhere. Let's see this. And I'll talk about the parts in a bit. Yeah, it's going to jump right off of there, I'm sure. All right, so the first thing, he's on the network. He's running a little Wi-Fi adapter. And generally, one of the ways you can usually reach him is he's got his own domain, but his own name, beaglebone.local is a host name. But I will use something like scan on the land scan to find him. So if you didn't have him plugged in with USB cable, you can just look for him. In this case, Beaglebone, he's actually nicely, properly named, and it's working. So if I go ahead and do the wrong thing and log in as root, which all the IT folks in the room will have to forgive me. There I am. So I'm now on top of this little board. I've got a Beagle Rover directory, and in here I have Rover server. And if you notice this, anybody that's used Express before, this is essentially, with the exception of that crazy thing called ngrok, which doesn't really belong here, but this is essentially a default app that will get created if you do an Express, like Express create an app. It's your basic framework. And the main part of that is app.js. So if we look here, ooh, that's ugly. That's still ugly, but okay. Maybe slightly less ugly. I don't know how much detail I need to go into here, but almost all of this is default. This is all boilerplate code. So this is Express. It's a framework used for creating web servers in JavaScript. And essentially, this is all out of the box. What I added here is this, right? So what this is doing, it's requiring a BoneScript library, which comes installed on the BeagleBone. And this is your JavaScript library that you can use to interact with the hardware. And a couple of things you see here, if you remember that diagram I showed you, and each of those little pins had the little identifiers. Those are these guys. So when you look inside where I've plugged in, you can see some wires plugged in. That's exactly what these are, right? So basically I'm saying I'm gonna turn this port here into an output port, and I commented that that's gonna be my servo. I'm using a motor controller. So port 14 and 16 are pulse width modulation ports, and 21 and 22 are as well. And that's just really a fancy way of saying I can send a special kind of signal on those ports that a motor can respond to. It's just a pulse. It's essentially allowing me to change power level for the motor, so it's not all on or all off, but I can actually gradually ramp it up and ramp it back down. So that's all this is doing. This is basically saying, all right, map these as outputs. If you've ever used an Arduino, it's a similar thing. You kind of set this up at the very beginning. And then right here, I'm taking this port 13 and I'm writing an initial value to it, which is just 60. Essentially, it's 60 hertz is the servo. I don't want to get too technical there. And then this is the position that I'm putting it in. It goes from 0.01 to 0.09. All right, so then we look down a little further. We've got, we're running on port 9000. We've got a directory called views, which I don't even know that I'm actually using it. Probably get rid of it. Yeah, I don't think I am. I'm using public, and I'll show you what that's for in a minute. This is all still boilerplate. I don't think I actually changed any of this. So the reason views and Jada there, that's just what came out of the generator. So if you look at how much code I've written so far, it's this, right? That's not a lot. And then, it's got the little environment piece. This is boilerplate as well. It lets you override certain things in different environments. So then, yeah, users. I didn't create any users. All right, so we have forward, back, left, and right. Now this I did do. You can tell because it's probably not right in some fashion. I'm sure that this should be RESTful or something cool like that, but it's not. It's essentially what I'm doing here is that part that I was talking about where Google needs an endpoint. It needs a URL to call back to from its button. So I'm saying, all right, if they call forward, then I'm going to write 1 to my left motor. So if you look at this, or forward is writing 1 to both motors. It's basically saying both motors should move forward. And you need to go back to that little comment thing that shows you what these little identifiers mean. So note to self, I probably should have done something cool, like rename them something that was a lot more intuitive than what this is. So this is code that was written, I'm not going to apologize for it, but I should have probably done that, yeah. Back, same idea, but now I'm hitting those ones that with a reverse direction, right, on the motor controller. So it's still putting full power reverse, full power forward. You can see here, none of these are actually going less than full power, but there's a possibility to do that if I wanted to. Left is essentially saying, well, turn one motor one way, the other one the other way. So I've got one going forward, the other one going backwards. Same thing with right.
What's the third parameter of the analog right, the 2000?
So that is the frequency of the pulse that we're sending. So it's a PWM port. So this is a 2000, I think, hertz. So it's sending a pulse to the motor. And that's the frequency at which the pulse is going with a full-on power. So it would make more sense if I was going at half power. But it is one of the parameters. And in fact, if you like, I could show you the API reference, which is also actually embedded on the board. All the documentation is right on there. Does that help? Okay. And then the last one, I have stop, just to turn everything off. Okay. And then I have an angle. This is for the little servo here that holds the thumb. So that's all well and good. All this stuff does, it's pretty straightforward, right? You have some URLs here that we're responding to, and we're calling straight into the library script for the Beaglebone, called Bone script. So the way I would start this, I just node app.js. Oops. And I'll run it in the background. It should give me a little message that it's coming up on port 9000. So this is running locally, right? And I need to make sure it goes outside of this local network. So there's a couple ways to do that. One utility is called ngrok. It's free. N-G-R-O-K. You guys saw that. This is one that I use. Like if you wanted to show somebody something that's on your laptop, it's really cool utility. Both ngrok and forward do this. But what this did, it just said whatever's on port 9000, it created an SSH tunnel for me. And it said externally you can reach it here. So that's pretty cool. I can now hit my robot. Don't do that right now, by the way. Please. But you could hit the forward in the back. So somebody's probably going to be.
He was right there.
Yeah. Do this now. Okay. So you got that. So then the next thing is well, okay, that was one part of the code. What was that, about 30 lines of code? That's highly generous. I don't think I even wrote that much code there. The other thing we have is this bot hangout. And this is the piece that Google needs to know about. Ooh. Oh, you know what? This is a C data block. Great. So let me do this. Let me look at the GitHub. That should be a little better. Do that. It might be easier to read it there. Sorry. So it's under my repository on GitHub. It's all publicly available if you want to look at it. But under public here, there's bot hangout.xml. And this is essentially, can you guys read that? Yeah, okay, great. So this is boilerplate stuff from Google as well. I'll show you how lazy I am. I never write any code. It's all boilerplate stuff. But this is stuff you get when you go to their little tutorial site on how to get started. And I have to say, of all the stuff that took the longest, it was this. And I'm embarrassed because this is, like, when you look at the code, you'll be like, why did this take you so long? It took me so long because I had a very serious error that Google gave me. And the error was essentially something went wrong. And I looked at that for a really long time, trying to figure out what it was that went wrong. Well, what it was this little C data block here was not closed properly. That's what was wrong. And so I can't blame them. That's probably not something they could have done much with, but it would have been nice if they said, like, unable to parse XML or something like that. But yeah, this doesn't look any better because, of course, this isn't syntax tiling either. All right, so I'll just have to talk through this. this is Boilerplate. It all comes with what they give you as a sample is this beginning piece, which basically includes something you get to define for your, this is just descriptive on the Google Hangouts. It has no, other than features they use, it doesn't really do anything other than describe the model that I'm creating. And then they give you this little CData block that's kind of empty with just this piece. So this says, you know, we're going to include support for your Hangout. And the rest of it is up to you. So all of this here, from here on down to the end of the CData block, I got to fill in, right? So that's the rest of the code for this rover. But it's also not all that much. And I'll probably get chastised by you guys. I'm sure a few people will say, why are you using XML HTTP request? But I'm that old, so that's what I do. There's probably much better ways to do this, but I'll walk through it a little bit. So I have a function that actually is going to go do the request. I tried this actually in an iframe, thinking that I could automatically get this to happen whenever they click the button. But something terrible happens in Google Hangout API with that behavior. At least didn't work in Chrome. I expected it to automatically update. So I ended up, it's a little bit of a hack for me. What I want to do is when someone presses a button, then I want to call my little URL, right? So I'm really just making an AJAX request here. I'm just forcing it. I'm saying, okay, this is going to happen whenever anybody clicks a button. And then you're going to see there's only really two calls. One that actually takes an extra parameter, which is tilt. And that's taking an angle. That's so I can move the phone up and down. And one that's for moving in a direction. So this is essentially saying whatever direction they want to move, just call the base URI plus the direction. And I probably could have done something similar with tilt and maybe saved even a little bit of code there. And then the rest of this is what actually displays in the Hangout. So I just created a div and a table where we have little buttons, right? It's really old school. But the only thing that's cool here is some HTML5 thrown in so that I can get some credit. Little slider input, and that's basically calling the angle. So any questions on this? This is fairly simple, even if you're sort of new to JavaScript. This should be, all this should be doing for us is really displaying something in Google Hangouts. So let's give it a shot. Let's see. Bring it over to the Google API console. So when you go to Google, they have a number of places where you can define your API. And I created one called Hangout Rover. They actually want you to host this XML file. So I showed you guys this earlier. This is the one we just looked at. And it's in my public directory, being served up by that little guy. So one thing you can choose is whether it's an extension or a main application in the center. This is just an extension. It's going to run on the side. If you are publishing this for other people to use, you need to include a license and some images, a number of things to allow it to legally be public. I'm running this in developer mode right now, so I will just show you this. So all this is saying, okay, where's your Hangout XML? It's the thing that describes what your root control is. And then, what images you're going to show for other people that are using this. You can then go in development mode and enter Hangout. So what this should do, sit up here. It's going to ask me, who do I want to hang out with? And this is probably the one piece that I still want to do a little work on. I want to have this be an automatic, either the robot will always accept the Hangout, or it'll be in a room that'll always be on, and then you're from another room. So when you see this, you see that it's come up with, let's see if I can get this guy. I'm going to invite my wife who runs me her account. Should give, okay, so what I would like the robot to do is automatically do that part that I just did. Which would just be either it'll automatically accept the invite or it'll sit in a room and already be there. So it's trying to connect right now, and we'll see how our internet connection is. going. There it is. So we see he's over here. You can move forward. You guys aren't seeing it. But one of the things you can also is go up. You can look up and down, and we can turn right and come over here. So the idea with this is essentially you'll see me on that phone, right? I can actually talk to someone on the other end, and the goal here ultimately is we would connect this to a larger robot that will be based off of a Roomba. And the reason we would pick the Roomba is because the Roomba, A, we can put more weight on it. I'm sorry, just calling you out there. I'm going to put somebody else. Yeah, so that's basically the idea for this little guy. He moves around, he can move the phone wherever we need it to go. And you know, the slider here is so you can look up and down and just do the different angles, right? So if you need to look down and see what's in front of you, or if you happen to need to look up. But yeah, that's essentially it for the robot. It's been really a lot of fun to build, and I'll talk a little bit about the parts. I think I have about maybe 10 minutes left, roughly. So,
One question, how did you get the video feed into the code base?
Okay, so who's been, anybody want to take a shot at that? How did I get the video feed to come through? Right here.
The Google Hangout app on the phone.
It's kind of lame, right? Yeah.
Easy.
Yeah, so it's basically my phone is hanging out right now, right? And all the robot is doing is moving the phone around. It doesn't even see what's coming in the video stream. That's like Google Hangout connected to my phone. The phone happens to be on a robot. The thing that's cool is these little controls inside the Hangout that let me move the robot.
Yep.
But yeah, it's kind of low tech, right?
$80 a month.
$80 a month. Yeah, well, I mean, you could do it with a tablet, and the tablet can be on Wi-Fi also, right? So it doesn't have to be a phone. So you can go a lot lower than that. In fact, free, I would think, right?
So is your face on the camera?
Yeah.
That means your face on the phone?
Yes.
Yeah. Well, whatever happens to be on my camera, I'm over here. It would be, right? It should be. Yeah. So I use the robot to turn it. You could certainly put a second servo if you wanted to. But I did the tilt up and down, and I figured to turn left and right gives me that. Otherwise, I thought people might get confused if they turn the camera left and it's moving forward. They'd be like, lost track. I figured it's the same effect anyway. But yeah, it looks kind of creepy with my face on there. All right, let's go back to this. So a couple more things to talk about. You know, the code is up on GitHub. You guys saw that. There's a couple things I want to tell you about the hardware. And this is another thing that's really cool right now. Again, this stuff was super expensive in the past, right? These motors here were $8 each. This platform, I think $6. The servo you can get at Radio Shack. I mean, you can get them on Amazon for like $6 or $7. The most expensive thing here is that USB battery, which is a backup battery for my phone, but it doesn't need to be that big. The one I have here is the Mophie. Interestingly enough, it does have to have 2.1 amps to drive that Wi-Fi. That was also another fun part of debugging. Then I used some PVC pipe. And then the thing you see over here is a motor controller. And what this is for, essentially, when you use a microcontroller, like either the Pi or the BeagleBone or even the Arduino, there's only so much power that you can run through the ports. So what you want to do is you want to put your power on a separate loop. And they call that, you know, an H-bridge for a motor, essentially, so you can go forward, backwards. People used to build them on their own and be like really proud of the fact that they built this thing with transistors that debugged it forever. Now you can buy these chips. That's not the 293. I think it's a 298, L298 from, I don't know, I'm not sure who makes it. But you can buy that chip somewhere. You can get this controller board. The chip is $3. The controller board is $8. Just get the controller board. Save yourself the hassle of trying to figure out how to make all those pins work right. But it's incredibly cheap, right? This stuff would have cost hundreds of dollars in the past. So again, very accessible. And then I just use a little old $2.99 iPhone rubber case that's onto a little piece of wood. The wood is actually a wooden ruler that's been cut. So I got the little angle, kind of low tech. But the idea was really just, can we put it together? And then, so can I do this on a Roomba later? That's the next one. And the Roomba should actually be easier.
How did you power the motor shield? I don't see an extra cable.
So this power right here?
Yeah.
So what this does, it takes VCC and ground, right? And if you remember, there's a pass-through on this board.
Okay.
And the pass-through for VCC goes up to 2 amps. So I could have gone straight from the battery to there, to the motor controller, and that might have been safer. If I have a bigger motor, like a multi-amp motor, this wouldn't be good for my board, the way I did it. But it wouldn't be a big deal, because there's 2 USB ports here, so I can put another one in. But yeah, you generally want to take your motor power and separate it out from the rest of the CPU. You want to share a ground, and that's a lot of people miss that. You put the plus and minus on the motor and plus and minus on the board, and they put a control wire over the motor, and nothing happens. You need to have a common ground in order for the controller to know what it is you're doing. So just to get a reference value. Yeah, so these parts, fairly cheap. It's not much, I mean, from a sort of very basic electronics understanding to then assemble this stuff and just put it together. So all in, this is no more than 70 or 80 bucks of parts, and I'm including the BeagleBone in that, not the phone. The phone is, obviously a lot more, but everything else, BeagleBone, battery, all in, you're about $70 or $80, which is kind of a robot. It would take a long time. And the first thing, I mean, a lot of money in the past, but the first thing people want to do when they build, or when they get into like microcontrollers, is build a robot, do this. Right? It's almost like I want people to do this so they can do something more interesting. Because once you build this robot, people tend to say, oh, the possibilities are endless. I got a little thing with wheels, but there's nothing else you can do. Right? That's pretty much it. So, I mean, it's fun to hack toys. It's fun to, like at Radio Shack, they had this little walking, spider bot. I hacked one of those, and it's kind of fun to do that. But the best thing to do is to get into the electronics and to think about what it is you want to build, and then build that. I can say that to everybody, but if you haven't done it yet, you're going to build this first. It always happens. It doesn't matter. So I would say go to a place like Hobby Parts and get yourself the wheels and everything together so you can drive around and get it out of your system. And then you'll do something after that that'll be essentially, well, this was cool. I did something fun. So if you want, there's I put a video together of him on my blog at skiptree.com. If you want, you can watch that. You can go to the GitHub and get the code if you like. And I'll certainly stick around afterwards and answer any questions. Also, I said I'm with ThoughtWorks. This came out of our 100 Days of Hardware competition. We are now in Atlanta. In fact, we're actually going to be right at that Colony place, right across Colony Square. So we're getting a new office there in May. So maybe you guys would let us host you every once in a while. We would love to do that. And we're also always looking for people, so if you're interested, I have one of my partners in crime here today, Ryan. She's from ThoughtWorks. So if you guys are interested in ThoughtWorks or interested in the rover or anything like that, feel free to talk to me. Any questions on this? Yeah?
I have a real general question about the servo.
Okay.
How did you make the servo work?
The servo?
What signal did you have to send to it?
So
just plug it right into the board and it just worked? Or
have you used a BeagleBone before? Is that why you're asking? Or
no, I've tried to use a servo before. It couldn't make it work.
So it's an analog write. Let's see if we can go to just the board, and I'll show you this. So when you get one of these guys, all the documentation is included in it, and you can actually. This is running on the BeagleBone, right? So you can look at the API here. This is all the stuff that you might want to run. I believe I used analog write for the servo. And again, it's showing you that little graph that I gave you, and it gives you an example of the code. And what's really cool is this will even, like if I want to run it, because it's JavaScript, that's cool. You can just run it in the browser. You can actually even mess with it in the browser and make some changes. So incredibly accessible. Obviously, this is not a servo, but what you see here is I put the servo on an output pin. So that's my servo port. And then this was the part that I had to mess with, because this is a 60 hertz, and you'll notice that's a little different for the one thing. Like the motors are all running at 2000 hertz on their pulse width, This one is running at 60, I'll show you. And I had to look at the servo specification for that. That was like, I think most servos run at 60 hertz. See right here, this guy, 60 hertz. So what I could do, well, yeah, you can see the, for instance, if I want to, should move his angle.
Wasn't it a colon?
Did I kill the stop
Wasn't there a
line?
colon
There, colon? What'd I do?
in your code? I thought it was a colon in the value.
No, it should just put the, I guess just put the value right there on the angle. Oh, anyway. Yeah, so that's working at least. I can, I will use the debugging techniques that we were just introduced to. Let me add debugger right here and see what's going on. Anyway, yeah, so you can play with it directly through the IDE, or you can build your own app and have a web server running it. The easiest way is just go ahead and hit this BeagleBone manual, the Cloud9 IDE, and just play with that. There was a question back here too? Yeah.
No, I was just curious, like, you said it required the Wi-Fi required 2.1 amps?
Yeah. So not the Wi-Fi itself, but what happens if I put the Wi-Fi dongle in this board and I run it with a straight USB power? This took a long time to figure out. Even if I'm running it off the laptop, right? I've got it plugged into USB. You get about 500 to 600 milliamps coming out of the laptop. So I was wondering, why is the Wi-Fi not working? And sometimes it was working when I had it plugged into my battery, and I only recognized it while the battery is actually giving it more current. So I think it doesn't need 2.1 amps, but it needs somewhere around 1 from my experimentation. Somewhere around 1 for the board to run with the Wi-Fi dongle working. That Wi-Fi sucks up quite a bit of juice. This dongle.
Well, the Wi-Fi is usually run at 5 volts, right? So
yeah, this one's running.
So,
Yeah.
so 1 amp would be, I mean, that seems like a lot of
draw. Well, 1 amp for the whole board, right? So the CPU is running, everything else is running, and it's got the dongle embedded. So that USB port needs all the power that it can get to run the Wi-Fi dongle.
But I'm just surprised the Wi-Fi requires more than the sorry.
The whole computer?
No, actually more than the wheels or more than any of those other devices.
Oh, yeah. Yeah, those are small motors on the wheels, but I would think that is surprising, right? You would think the wheels might be a little bit more. The motors are not that big. It's a geared motor. It's a small little DC motor.
I'm just thinking they'd still need a lot of torque to...
Yeah, I imagine that if I had run this on 500 milliamps without the Wi-Fi there, and I tried running the wheels, if it ran into something, it might run out or something. It might have that problem. If there's any kind of pressure against the motors that would cause that current load to go up, I think it would be a problem. But right now it's not, right? At the 2.1 amps, it's got plenty of use.
Dongle's probably designed for a laptop or something like that. So
Yeah.
where it's not going to be starved.
Yeah. And again, I don't know, but with just using this USB power to power both the board and the dongle, the best. So, lesson for you guys: if you have a BeagleBone and you're trying to do the Wi-Fi dongle thing, which also it's an adventure to set up. Think about the power. All right. Any other questions? No? All right. Thank you so much. I appreciate you guys.